In this video, we will do an example involving committees that have a president, a vice president, and some general members. So the example says that a 5-person committee comprised of a president, vice president, and 3 general members is to be chosen from a group of 15 people. How many different ways are there to do this? So I want to begin by letting you all pause the video for 3 minutes to try this question. 4, 3, 2, 1, pause the video. Pause it for 3 minutes to really try this. All right, so hopefully you've done that. Hopefully you paused it and tried this question. This may not have been enough time to finish the problem, but hopefully you were able to get started and think about what some of the key ideas might be. So overall, we are picking 5 people here. And one of these people is going to be the president, which I'll call P. One is the vice president, which I'll call VP. And then 3 of them are all general members. So I'll just write Gen here. So when it says that there's 3 general members, that means that those 3 general member roles, positions, are identical. So if I were to place people into these slots one by one, it matters who goes in the first slot and the second slot, because they're going to be the president and the vice president. So order matters for the president and the vice president, but it doesn't matter the order in which I place the last 3 people. Even if I were to switch the last 3 people around a little bit, they're all in the same role as a general member. So I'll say, but the order does not matter. Does not matter for the 3 general members. Okay, so thinking about our strategy for this question, let's do this in a few steps. First, let's pick the president. So who's going to go in that first slot? Then we can pick the vice president. So who's going to go in that second slot? And then 3, then let's collectively do the general members. So pick the 3 other, let me just say, pick the 3 general members. Okay. So for the president, there's 15 total people in the group. So there's 15 ways to choose who's going to go in that first slot for the president. And then once I've picked who goes in that first slot for the president, there are 14 ways to choose the VP, the vice president, based off of that. And then finally, for the 3 general member spots, let's think about this kind of in broad terms first. There's 13 members at this point left to choose from. Once I've picked a president and picked a vice president, 13 members left. And we are choosing 3 of them, and the order doesn't matter. Okay, so we're going to use combinations. And when we use combinations, I'm going to practice my notation for combinations. So we'll do 13, choose 3. And I put those in these narrow parentheses. So 13, choose 3 ways. So we'll remind ourselves, how do we work out what that is in a sec? But let's see if we can put this together. I'm trying to count the number of total such committees. Okay, so because these are all steps, 1, 2, and 3, of this process of selecting a president and vice president, we are going to multiply the values we got from these 3 steps or stages. So we'll multiply the 15 with the 14 with 13, choose 3. Okay, so this is 15 times 14. So I always like to think conceptually about, like, what is 13, choose 3, and get a good conceptual feel for it rather than relying on the formula, especially in the early going, because I think knowing conceptually what it means is super important. So 13 choose 3. So we're picking 3 slots or 3 members from the 13 remaining. So there's 13 ways to choose who goes first. And then after I pick that first one, there's 12 left for who goes second, that second general member. And then once I've picked those first 2 general members, there are 11 people left to choose from for who's that third one. But it's not just 13 times 12 times 11, because that overcounts. That assumes that the order in which I pick those 3 general members matters. But once I pick those 3 general members, there's going to be 3 factorial ways to permute them, and I need to divide by that, because that's how many times I would have ended up overcounting by. All right, so plugging this into a calculator, we end up with 60,060. And that is our answer. So in terms of our goals for this section, we finished our last goal, which is talking about a few examples in which we count objects that required us to use multiple techniques. So for example, in this video, we did an example that involved both the multiplication principle as well as combinations.